Good morning, participants, and welcome to the third session on Janaganit geometry. Can we do the Facebook Live? Yes? And we are now also live on Facebook. Has that link been activated? So today, we will begin by doing a little bit of revision about what we had done in the last session. You will recall that in the last session, we conducted certain activities. The first activity was making a line segment with the broomsticks. And we made line segments of different lengths. Thereafter, we used these line segments for making a triangle. We found out how to make a triangle using these stick line segments of different lengths. From there, we went on to make a triangle in two ways. One way was using these line segments, stick line segments, and the other was by using a compass and scale. From there, we went on to making an angle. The way we made an angle, I just want you to recall that. Like we made a line segment from a stick, we made an angle by taking a circle, a paper circle, folding it in half along a diameter, and then cutting angles from the center to the circumference. You recall that? So we made three angles, A, B, and C. We made from the other half three other angles, A dash, B dash, C dash. That is how we made angles. In the last session, we did not make angles by using a compass and a scale. We did not make angles by using a protractor. We made angles by cutting them out from a circular sector. And then we experimented with adding angles. We found out what is A plus B. We found out what is A plus B plus C. And then the final activity that we did was to try and make triangles using three angles. And we found out that A plus B plus C If it is 180 degrees, then we can indeed make a triangle. But if A plus B plus C is not 180 degrees, then the three angles don't fit when we try to make a triangle. That was what we did in the last session. Now let me tell you about today's session. First, let me remind you that this entire program, Janaganit mathematics, we will, over the next 7 months, we will try and cover all the important concepts in mathematics for class 6, 7, and 8. Some of the sessions will be joint sessions. In fact, many of the sessions will be joint sessions like today's session. Today's session is a common session for class 6, for class 7, and for class 8. Why are we having joint sessions? Please understand that the main reason for having joint sessions is that some of the concepts are basic. They are basic for class 6, they are basic for class 7, and they are basic for class 8. And what we are doing today and what we did in the last session is basic for all three classes. Later on, we may do some sessions which are special sessions for each class. We will announce that each time. But every week, mostly on Saturdays at this time, we will meet for, I'd like to also, I'm happy to tell you that last time, if you recall, I had said that this program will also be taken up in the other languages of our country. And I'm happy to tell you that since the last session, which was on the 5th Teachers' Day, the session, a parallel program, Janaganit program in Marathi, has been started since 6th September. And tomorrow, the second session of that program will be conducted. So now we have the program today here in English, tomorrow in Marathi. And I'm also happy to tell you that very soon a program in Hindi, a special program in Hindi, will be conducted. Now, the last time we had used both English and Hindi in the presentation, but since we are going to have a dedicated program in Hindi, today I will use only English. And as we go ahead, I hope that we will also be able to start the program with other of our national languages in Malayalam, in Tamil, Kannada, Telugu, Bangla, Kashmiri, Assamese. Because this program of Janaganit, as you know, our national anthem is Janaganamana. Janaganit is a program which is intended to reach every citizen in our country and make everybody comfortable in mathematics. Now, all of us who are working together, we have formed a collective of different organizations. And this collective, we have called it Everybody Can Do Math, EBCD. Everybody can do math. And I hope after the last session, where we did some math, we handled some math, I hope, like us, all of you are convinced that everybody who is participating in this program can understand, can master the concepts that we are discussing. So let us now proceed. Let me tell you briefly what we will be doing today. Today we will continue and we will be discussing the main constructions which are there in school geometry. For example, what we do today is covered in chapter 14 of class 6 of the NCERT mathematics curriculum, mathematics textbook, chapter 14 of class 6. And what we are doing today is also covered by chapter 17, the textbook for class 6 of the Maharashtra State Board. So after doing these activities, please go back and if you are in chapter 14, if you are in the Maharashtra State Board, you can read chapter 17. If you are in other state boards, please look up the chapter on constructions, because what we are doing today is very relevant to constructions. Are we ready to proceed? Are there any questions about what we had done last time? Shall we just take a minute's break and, not a break, but we'll take a pause of 1 minute and we will listen to any questions that you had about the last program, previous session. Anybody would like to ask a question, please do so. So what Arnav has done is he has made a triangle using a compass. The same triangle, 5 centimeters, 6 centimeters, and 8 centimeters. Now, Arnav, please put your rods which you have made on the triangle and see if they fit. Very good. Thank you. Can I have the camera back on me? So as you can see, we have made a triangle in 2 different ways. One is by making line segments and putting them together. And the other is using a compass. Okay. And both the triangles made in 2 different ways, they each other. That is revision. That is what we had done in the last session. Remember, in the last session, we had not made an angle using a compass or a protractor. We had made an angle by cutting, making it physically, by cutting the angle out of a circle, a half circle, cutting circular segments along a paper circle by cutting along the radius. So today what we are going to do now is to make angles using a compass, and a scale. That is the next activity that we are going to do. So, can we have the next slide, please? Next slide.
No, miss.
Okay. Recall that we have not made an angle using a compass scale in the last workshop. In the last workshop, we made a physical angle. But now we are going to see how to use a compass to make a angle using what we have learned in our last workshop. So I will do the activity here, and Arnab will do the activity also. Keep the camera on me, and let us do that. Let us make an angle using a compass. So what I do is I take a scale and I make first an angle. I want to make another angle which is equal to this angle using a compass. Let us see how to do that. Please take the camera back. So what I do is first I take the compass and give me the compass. That's your compass. I'll take my compass. I will call this point here as point A. And I will make by taking any length of radius and drawing two arcs which cut the two arms of the angle. So let me call this point here as B. Let me call this point here as C. Now, I have made a triangle. ABC. I know how to make another triangle which is the same size as this triangle with all the lengths, line segments equal to the line segments of this triangle. So let me do that. I have the compass at the same distance. So I keep it here. And what I do is I draw another line. Arnab, you can see what I'm doing. I draw a baseline. I call this point P. And what I do now is I draw a circle, a section of the circle, an arc equal in length to AB. Similarly, I cut this line here. Let me call this point here as Q. And then I use the compass to get the length equal to BC. I move it here to Q, draw a circle with radius equal to BC, and I get this point here. Let me call it R. And as you know, because that is what we did just a little while back, that is what Arnab did. Now we can construct this triangle here. So this triangle PQR is the same as triangle BAC. And since these two triangles are identical, are congruent, angle A is the same as angle P. Okay, please take the camera back. Let's recall what we have done. Can we have the slide presentation, please? Can we go back? Yeah. This is what I have done. And now I am going to go over to Arnab, and we will do that activity there so that you can also do it yourself at your wherever you are located. Okay? So now this is the angle. Can we have the camera here?
Okay.
Can we have the camera here? So what we have done, we want to make an angle equal to this angle. So what is the first thing that you did? You took the compass. Keep the camera away. Take the compass, keep it here. And what did you do? Take an arc. Okay. So we draw it there, and we draw it here. Okay, any arc. Call this point here B and call this point here C. Take your pen. Call this point here B. Call this point here C. Okay. Take your eraser so that we don't get confused. Okay. All right. Now draw another line here and keep the compass at the same distance. Don't change the. Make it a little bigger. Fine. Now take a point here, call it as P. And now take the same distance here, keep it here, and draw an arc from here. Keep it here. Draw a big arc cutting this line here. Okay. All the way up to here. Go. Okay, that's fine. Now call this point here Q. So how is AB related to PQ?
The distance here from this A to B and from B to Q is same.
Okay, say it a little loudly.
The distance from A to B and P to Q is same.
Why?
Because the measurement which we took the distance from this point to this point was same at here also and here.
Also. Okay, that's right. Now measure the distance from B to C using the compass. From B to C, measure that distance. Done? Okay. Now keep the point here at Q and draw an arc cutting this arc. Very good. Call this point here as R. Okay. Now join P to R and extend it. Join P to R carefully. Extend it, extend it. Okay, fine. And join Q to R. Okay. So we saw that AB is the same as PQ. Okay. So here, join BC here also. Okay. So how is BC related to QR?
This measurement is the triangle to measure all the sides, and if, by using a protractor to measure its degree, it would be the same.
Right. But how is QR related to BC?
The measurement here, if you measure with the scale, it will be same.
They will be the same, right? Because you have used the same measure from the. You have not moved it. You have used the same length. Okay. All right. So now, can you measure this angle here with the protractor? How many degrees do you get?
It's 70 degrees.
Around 70 degrees. Okay. Measure this angle here. It's also 70 degrees. Very good. Can I have the camera back? Right. Okay. So, as you can see, we have made two triangles which are congruent to each other. And since the triangles are congruent, the angles are also equal. The angle at A is equal to the angle at P. All right? So now we know how to construct an angle equal to another angle using a compass and a scale. All right, are there any questions? Any questions from the participants? Okay, if are there any questions? Shall we continue? Let's go on to the next activity. So now we know how to make an angle equal to another angle. So your homework problem, next slide please. Slide number 7. Homework problem is to do the same thing what we have done just a little while back, which is to draw any angle and make another angle congruent to it using a compass and a scale. Okay, that's your homework. Now let's proceed. Next slide, slide number 8. Now you have your broomsticks. So it says here cut 8 sticks each of 5, 6, 7, and 8 centimeters. For the time being, just make 5, 6, 7, and 8 centimeters. I think you already have done that, Anup. So please take your rods of different lengths and keep them here. 5 centimeters, 6 centimeters, 7 centimeters, and 8 centimeters. Let me just confirm that. This is 7 centimeters. This is 6 centimeters. This is 5. Okay. This is 8. And what we have to do now, Arnab, we have those 8 centimeters. Please make a rod of 8 centimeters. Okay, you have them? Yes. Now please make a quadrilateral, a 4-sided figure by putting those 4 of them together. Have you done it? Okay. Now, you have done it there, and I have done it here. I also have used 5, 6, 7, and 8. So have you. But your quadrilateral is different from my quadrilateral. Yes. Right? So what does this show?
There is different arrangement lines, line segment, with the different elements of them.
Right. Okay.
This one means this is like it is going straight to each other, and
Here the angles are different. Yeah, your angles and my angles are different. But
only to right
but
and acute.
but if you take away the 5 centimeters, I will take away my 5 centimeters. Now make a triangle.
Then
This is how much? This is 8. This is
this is 6, this is 7.
okay. Let me just check. This is right 8. This is 6, and this is 7. Right.
Yes.
So now I'm going to make my triangle using my rods, and you are making your triangle using your rods. And what we see is that these two triangles are looking the same.
Yes.
So for triangles, if I have the lengths same, the triangles are the same. But for a quadrilateral, it's not enough.
Because the base we have put the same. For 8 centimeters is the base.
Okay, now you take your 5 centimeters and make a quadrilateral. Now, are these the same?
No.
They are not the same. Okay, so for a quadrilateral, having the same lengths will not give you a single quadrilateral. You can make many quadrilaterals with the same length by changing the angle. Okay, now let's continue the discussion. Yes, you can move yours. So now take 4
Yes, sir.
line segments of length 6 centimeters. Take 4 line segments of length 6. This is one.
Same, and also
Let me make another.
this one line segment.
So this is what I have made. And can we have the camera on what Arnav has made? I will keep mine next to what he has made. Are they the same?
No, this is a square and this is a rhombus.
Right,
So they are different.
right.
The rhombus has different angles. Square has 90 degrees right angles. Rhombus has acute here and obtuse like this.
Okay,
Then obtuse.
okay. What is the definition of a rhombus? What is a rhombus?
A rhombus is a quadrilateral of a shape of a kite.
What is the property of a rhombus?
Meaning all the length of all the sides is the same.
Right? If the length of all the sides is the same, then it is a.
Rhombus or a square.
So is a square a rhombus?
No.
Why?
The angles are different.
Or can we say that the square is a rhombus whose angle are 90? Can we say that?
Yes, yes, you can say because we can like change a rhombus into a square.
Correct. So a rhombus is where all the sides are equal. For a square, also all the sides are equal. So the square is a particular kind of rhombus, a rhombus whose angle is
Angle is right, square is right angle.
right angle. So
On the basis of side, it is same, but on the basis of angle, it is different.
it is different from,
On angles, in angles.
yeah, a square is a particular kind of rhombus, right? A square is a rhombus which has angles 90 degrees. If it is not 90 degrees, also you can have a rhombus. But when the angle is 90 degrees, then it becomes a square. Okay, all right. Can we just have the slides again, please? So slide 9. This is what we did earlier. Slide 9. Okay, next slide. Yes, keep clicking. So now we have made using 4 sticks of 5 centimeters, we have made a square and we have made a rhombus. The next slide. So a quadrilateral having all 4 sides equal is called a rhombus, as we know. Next slide. We asked the question, is a square a rhombus? And we also discussed that. And we answered that yes, a rhombus is having all 4 angles at 90 degrees. Okay? A square. A square is a rhombus which has all 4 angles as 90 degrees. That is a square. Okay? All right. Now, can you make a rhombus with angle of 60 degrees using your rods? Can you make that angle 60 degrees?
Done.
How do you know that is 60 degrees?
Because it is an acute angle, then it is an acute angle.
I want it 60 degrees. So you have to measure using a, okay, please do that.
now it is measuring.
60 degrees. Okay. Can we have the slides again? Can we have the slides? No, keep it as it is. Next. No, just go to the next slide. Next. 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 Okay, just hold that. That is what Arnab has done. The Arnab used a protractor and made a rhombus with an angle of 60 degrees. Okay. All right. Now, we are going to do the same thing. Instead of making a rhombus with sticks, we are now going to make a rhombus with a compass and a scale. Okay. Please go ahead, Arnab, and make a rhombus, any rhombus, with a compass and a scale.
On this protractor to make angle up to 10 mil.
You want to use a protractor? Go ahead. Done? Okay. Let me see what you have done. You have made a rhombus. Show me your compass. Let me check that it is a rhombus. So it is this. Equal to slightly different here. Slightly out here. Slightly out here. Okay. So it is close to a rhombus, but a little bit. Now let us make a rhombus a little more accurately. Okay. So we'll keep sheet here. Yeah, keep that. So what is a rhombus? A rhombus is a take that as the base. Okay. Now let's take this point here and draw an arc. Okay. And then I want to take a point here. So let me draw any angle from here to here. We call this point A. Call this point here B. Call this point here C. So what do you know about AB and AC?
AB and C.
AB, segment AB and segment AC. What do you know about them?
They're equal.
They are equal. Why?
Because we drew the arc and the arc is cutting both this line. And once we draw an arc, it is going to be same.
Because they are the radii of the radius of the same circle, right? And the radius of the circle is the same everywhere. So that is why AB is the same as AC.
Yes.
Okay. Now you keep this as it is. And now take B as your center and draw
An arc.
a nice big arc on this side. Here. Draw. Okay. And take C as the center and draw an arc. And call this point here as D. Okay. Now join BD and CD with a scale. Okay. So now you know that AB is the same as AC.
Yes.
What about BD?
BD and CD both are same. Because we drew one arc from this point and from this point. And B and C, they means the distance is same here.
Right.
We haven't extended the compass.
We have not extended the compass. We have used the same compass.
Yes.
The same compass, when it is at A, it reaches up to B and C. When it is at B, it reaches up to D. Okay, from C also it reaches up to D. So what can you say about AB, AC, BD and CD?
It is a rhombus.
It is a
Rhombus.
rhombus. Why?
Because all the sides now they are the same.
They are all the same. So we have constructed a rhombus now using only a compass and a scale. Okay. All right. Now let us cut the rhombus out. Okay. So I'm going to cut out the rhombus. All right. Okay. So now let me call this angle here as A. Let me call this here as angle A. This here is angle B. This here is angle C. This here is angle D. Okay. And I want you now to divide the angle A into two equal parts. How can you do it?
I will fold it and then
No, I want to divide this angle here, into two equal parts. Okay? Very good. So you have folded it now into two equal parts, right?
yes,
So now this angle on top is equal to the angle down, right?
yes.
So when I fold it, what is this line? What is this line here? This line is AD.
AD.
This line is AC.
AD.
AD, right? What is this line called? The line AD is called the diagonal.
Diagonal.
Diagonal. This is called the diagonal of the rhombus. So there are two diagonals. There is this diagonal, and then there is this diagonal. Okay. So when I fold like this, I get the diagonal. Okay. Now, what Arnav has done by paper folding, he has divided an angle into two equal parts. Which angle? The angle A. The angle A he has divided into two equal parts. That is known as bisecting the angle. Now I'm going to bisect the angle here using only sticks. But I'm going to learn from what Arnav has done. Arnav has done it by paper folding. I'm going to do it by using sticks. Let's see how I do it. Okay?
Yes.
So let me first make a rhombus here. Again, I'll keep a piece of paper. And all these sticks are of the same length. So when I put them together, I will get a rhombus. Let me call the rhombus, let me call this angle here as A. This angle here as B. This here as C. And this as D. And I want to divide the angle CAB into two equal parts. I want to bisect the angle CAB. Now I know that when Arnav bisected his angle, he did it by folding along the diagonal. So what I am going to do, I am just going to draw the diagonal. I'm going to keep this rod along AD. That's a diagonal. So the line AD bisects the angle CAB into two equal parts. Okay. So that is what we have done. Now let's go back to the slide projector and go back to the slides and see what we have been doing. Arnav has been doing it in one way. I have been doing it in another way. Let's see what the slide presentation tells us. Okay. So we draw a rhombus. Slide number 16. Label it as A, B, C, D. Okay. Now, next slide. Yes. What can we say about its sides? Just hold this slide. That's what we discussed earlier. All the sides are congruent. What can we say about its opposite angles? We can measure and see that the opposite angles are also congruent to each other. And the adjacent angles, that is not something that we have verified, but you can measure the angles and see that the adjacent angles, that is the angle at A and the angle at B, that adds up to 180 degrees. Next slide. Yeah. The second line there is an error there. It should read fold the rhombus on line BD, not AB. It should be BD. What happens to the angle? Or rather, instead of AB, we can have AC. AC, not AB, AC. What happens to the angle A when we fold it like this along AC? We get two same angles. Hence, AC is known as the angle bisector of A. Okay? Not AB here. Here, AC is the angle bisector of the angle A. Now, let's continue. Let's take the same angle which we made out of paper, and now let us fold along the other diagonal. Okay, we have folded along this diagonal, along AD. Now fold it along BC. Exactly, yeah. Keep mark. Right. Done? Okay. Open it up. Now use a scale and draw AD and draw BC along the folds. Carefully draw AD and BC along the folds. Okay. Now, okay. Now you folded it like this first, and like this also. Okay. So what is this angle here? This angle here.
This is an acute.
Is it acute? Look at it carefully.
No, it's a right angle. It's a right angle.
It's a right angle. Okay. So this is a right angle. All right. Now I open it up. This part and this part, how are they related?
So
This length here and this length. How are they related?
the angle,
So this length here and this length here. How are they related?
they are exactly in the diagonal.
No, this length here, is it more than this length?
No, it is the same.
It is the same. So they are exactly
Half.
half of his whole length,
Yes, half of it.
right? And this length here, what about that? What can you say?
There are two halves.
There are two halves of which length?
A and B. A and B.
Right. So this center point divides AD into
Two halves.
two halves and divides CB into
Two halves.
two halves. So this point here, we can call it the middle point,
Center.
the center, the midpoint. Okay. And these angles here, let me call this point here as, this is A, B, C, D. Let me call this point here as E. Okay.
E is the center.
E is the
Center.
center. And the angle CED is?
CED is the right angle.
Okay.
Right.
Which are the other right angles?
So BED and AEC and AEB.
AEB. They're all?
Right angle.
Yeah. And E is the midpoint of BC and E is the midpoint of AD. So how much we have learned by folding a rhombus? Okay. So this rhombus that Arnav has made, by folding it, we have learned many things. We have learned that AD, the diagonal AD bisects the angle A. If we draw the diagonal AD and we draw the diagonal DC, we have learned that these two diagonals meet at a point E, and E is the midpoint of AD. E is also the midpoint of DC. So we have bisected AD and we have bisected DC. Bisected means divided into two equal parts. So we have learned how to bisect an angle. We have learned how to bisect lines. Not only that, but we have learned something more, that when we draw a rhombus, the two diagonals bisect each other, but not just that, they bisect each other at right angles. So AE is the perpendicular bisector of BC. AE is the perpendicular bisector of BC. And BE is the perpendicular bisector of DE is the perpendicular bisector of
A and D.
AD, right? So BE is the perpendicular bisector of AD and DE is the perpendicular bisector of BC. So let's now go back to our presentation. Go to slide number 19. Properties of a rhombus. Diagonal. We draw the diagonals AC and BD. What we have done may be a little bit different here because we have given the names a little differently. When we fold the rhombus, so we get the angle bisector of the angle A, as we saw earlier. Next slide. Now fold the paper once more to get 4 equal quarters. Open all the folds and observe. What do we observe at the intersection point of AC and BD? AC and BD are intersecting each other in a right angle. They are bisecting each other also. From all this discussion, we can say that both the diagonals are perpendicular bisectors of each other. Now, let me repeat here what we have done by paper folding. Let me repeat it by placing sticks. So here I have drawn one diagonal AD. I'm going to draw the other diagonal, BC. So when I make a rhombus ADBC, when I draw the diagonal AD, that bisects the angle at A. Okay? Secondly, let me call this point here as E. Let me call this point of intersection as E. So we know that AD bisects BC at the point E. We know that BC bisects AD at the point E. And moreover, we know that each of these angles here at E, this one, this one, this one, and this one, each of these four angles is 90 degrees, is a right angle. So what we observe is that we have drawn the perpendicular bisectors of the diagonals of a rhombus. And if we know how to make a rhombus, we know how to do many things. We know how to bisect angles, we know how to bisect line segments, we know how to draw perpendicular bisectors, we know how to draw a perpendicular from one line to another. All these things are all there in this exercise on the rhombus. So now let us continue with the slide projector. Go to slide 20. There's another way of also doing perpendicular bisectors, that is by measuring with a scale, then half the length, find the midpoint. But we don't need to do that now because we have so many different ways. We can do it by paper folding, we can do it with a compass and a scale. So this way, by actually measuring and using a protractor, we can also do it that way. You can do that as homework. Next slide, 22. Method 2, using a compass, we create a rhombus with the segment as one diagonal and draw its other diagonal. Slide number 23. So that's what we did. Okay, let's do that exercise now on the piece of paper. I think we are reaching towards the end of our time. So I'll just do this myself. Very quickly, I'll do it myself so that you can see what I'm doing. Okay, I will quickly do that exercise here, and you can repeat it for homework. So what I'm doing now is I take a sheet of paper, and I want to bisect a line segment. This is the line segment AB. I will call it AD. Instead of AD, you will understand why I'm calling it AD. Using a compass, I'm going to draw a rhombus so that AD is a diagonal of that rhombus. Okay, so I do it, doesn't matter what I do. I draw one arc on this side, another arc on this side, from taking A as a center, and I take G as the center. I don't change the distance. I draw an arc on this side cutting, another arc on this side cutting. And let me call these points as B and C. And now I join A to B. I join D to D. I join A to C. I join D to C. As you know, ABDC is a rhombus. We saw that earlier. And AD is now a diagonal. When you're actually bisecting a line, you don't have to draw all these four sides of the rhombus. I'm just drawing it now to make it clear that what we are doing really is creating a rhombus. But when you do it in school, you don't need to draw the sides of the rhombus. This is just to make things clear. Now, AD is one diagonal of the rhombus. I draw the other diagonal. And Arnab, can you put the camera on Arnab? I have drawn the other diagonal. So what have I drawn? And the other diagonal is what? Say it a little louder so that everybody can hear it.
The perpendicular bisector.
Yeah.
So we drew a perpendicular line in the first we joined on the sides by creating the arc, and then we drew a straight line from this point to the another one point to make it into a half.
Right. Okay, very good. Right, so here we have drawn the perpendicular bisector by using the rhombus property. Okay, so now let's go through the last few slides quickly. And now we are at slide 23. Go to slide 24. Angle bisector, by the same method, we draw the diagonal of the rhombus. Slide number 25. Use a compass and create a rhombus with one angle equal to the given angle, then draw the diagonal. Okay. Slide number 26. 26. Next. Okay, hold that, hold that. So that's how we drew the diagonal of the rhombus and we bisected the angle. Okay. So now, next slide. Okay, the homework is mentioned there. It says use paper folding, cutting and drawing to find the properties about sides, angles and diagonals of the rectangle, of the square, of the parallelogram and of the kite. So please take a screenshot of this. Let me add something which is not on the slide. Please listen carefully. Those of you who are in CBSE using the NCERT textbook, please read chapter 14. Chapter 14 is about what we have done today. And those who are in Maharashtra State Board, please read chapter 17 on constructions. Chapter 17 is what we have done today. In one day, we have completed both these chapters, chapter 14 and chapter 17. And as we can see, it all comes, if we know how to draw line segments, if we know how to draw circles, if you know how to draw angles, then we can do things like bisecting angles. We can do things like drawing perpendicular bisectors. We can do many things. Next slide. So please note the two sites, EBCD math, Janaganit, and everybody can do math. What we have done today will also be available on the YouTube channel and Facebook, Twitter, Instagram, maybe a little later because we are still sorting out the technical problems, but we will make all these available on all these platforms. And please get back to us with your questions. I'm sure that many of you have questions about what we have done today. We are still improving the platform, and we would like to improve it so that we can take these questions online. Maybe next time we will be able to do that. But any questions that you have, please write to us. Please send us an email. Secondly, any suggestions that you want to make, especially the teachers amongst the participants, if there are some suggestions that you want to make, please make those suggestions, because we want to improve with your suggestions. The objective of this program is that every participant should understand everything that we have done in the session, in every session. I will not ask you whether you have enjoyed this session, but I will ask you whether you have understood everything that we have done in this session. So please get back with your feedback whether or not you have understood everything. If you have not understood something, please write to us and tell us that this is the point that I have not understood. But I know that if you have understood everything, then you have certainly enjoyed what we have done, because there is a lot of enjoyment in understanding. And we are going to ensure, or try to ensure, that all the concepts will be done by doing and understanding. And if you are understanding also, I'm quite confident that you will be enjoying it. So please get back with your comments, with your questions, and we will meet again 1 week from now, most likely on the 19th of September. Thank you. Till we meet again.